How would a regular developer implement a save and load mechanic into their game? They might go with PlayerPrefs, use save files, or even go all the way and create a cloud save. What about me though? Of course, folks, I decided to create a fully functional standalone game server completely from scratch. It's been a month since I dropped my last devlog video walking you through the initial steps of creating a game server as a simple console application. I managed to set up a connection with my SQL database, write some basic data like the amount of gold to this database, and retrieve it when the game loads. Today, I'll show you my progress over the past month, share some challenges I faced, and give you a glimpse into the world of game server programming. For those who don't know me yet, my name is Yaroslav and I've been developing games for more than 12 years. I used to create small and simple Flash games, but since that technology became obsolete, I switched to Unity. For the last 3 years, I've been working on porting my most successful idle incremental game Get a Little Gold for mobile. Well, to be precise, currently I'm working on the server for this game. And that's exactly what we are going to talk about today. But first, let's understand how the save load system works in an average game. Imagine we have an enemy with a certain number of hit points. Each click on the enemy reduces its hit points by 1, and once it reaches 0, the enemy is defeated. However, as a player, you might decide to take a break after hitting the enemy 5 times. To save your progress, we need to store the variable containing the enemy's hit points either on the player's computer or in the cloud. Then, when the player decides to continue their fierce battle, we retrieve this information. Now, imagine we have added an option to increase your attack power. After upgrading your weapon, you can deal twice the damage to the enemy. In terms of the game save, we now need to store 2 variables instead of 1. We still need to keep track on the enemy's hit points, but now we also need to preserve the player's attack power. As the game becomes bigger and more complex, the number of variables we need to save increases. In my game Get a Little Gold, there are hundreds of different variables. The total data volume for Get a Little Gold save file can reach up to 10,000 bytes or 10 kilobytes. While this might not be a problem for local saving, it can turn into a real disaster when implementing cloud saving, as the server has to consistently receive this data from multiple clients. The question is, how can we reduce the size of the data sent to the server? Well, first of all, not every variable in the game needs to be saved. Take for instance GPS, gold per second, and GPC, gold per click. These values don't need to be stored as they are calculated during runtime. On the other hand, variables like the amount of gold producing buildings, which influence the GPS, should be saved. With 15 different types of buildings, we need to save the quantity of each one. Now, the variable containing this amount is an integer type, meaning it occupies 4 bytes. Consequently, the entire array of 15 buildings will occupy 60 bytes. In the current implementation, my game server receives data from the client once every 10 seconds. Essentially, this means that without optimizing the data volume, the client would send 60 bytes of information about buildings alone 6 times a minute. However, this data is often identical or almost identical, because players don't purchase buildings frequently. Even when they do, it usually involves an increase in the amount of only one building, leaving the other 14 unchanged. Another example is an array of learned upgrades. The array holds boolean values for each of the 290 upgrades in the game, totaling 290 bytes. Yet, players don't buy upgrades so often, so there is no need to send the entire array to the server each time we want to save the game. This principle applies to every other parameter or stat in the game. Despite having more than 60 savable parameters in Get a Little Gold, some of which hold hundreds of variables, like the array of learned upgrades, only a fraction of them actually change between server calls. Therefore, we don't need to send all 10 kilobytes of data every 10 seconds. The only data we need to send is the one that has changed since the previous server call. To determine which data should be sent, I created a special class that remembers which data has already been sent to the server. This process is exactly what the update data, huge method consisting of almost 800 lines of code, does. It compares the data that has already been sent with the current game data and creates an optimized small packet of new data that will actually be sent to the server. Let me show how it works. Firstly, we need to launch the MySQL database locally, and for this I'm using the XAMPP control panel. Let's start it. Now we can launch the console server application. As you can see, it has successfully connected to the database, indicating that our server is up and running and we are good to go. I've opened the server console and Unity editor side by side, so you can monitor what's happening on the server while the game is running. Now, let's start the game. After pressing play, a few things happen on our server. First, the client with the specified IP address, in this case localhost, successfully connects to the server. Next, the server attempts to search the database to find the user record. Finally, as the record exists, the server retrieves the data in JSON format, deserializes it, and loads the game. Now, let's take a look at what's happening on the server while the game is running. I'll clear the console window and expand it for easier readability. As I mentioned earlier, the game, or client, constantly sends data packets to the server every 10 seconds. We can inspect the contents of these packets by running the show packets content command. By the way, these commands, which allow me to communicate with the server, were another thing I was working on during this last month, but more on that later. After running show packets content, the server starts printing information about received packets, including their size and the actual data they contain. As you can see, the server has just received a packet with a size of 24 bytes. It contains information about the client that sends this packet and the timer information indicating how many seconds have elapsed since the game challenge started. Currently, the game is running, but I'm not actively playing, so the only thing changing is the timer at the top of the screen. Hence, the packet contains only information about time. However, if we actually click the gold generator, the next packet will be different. Firstly, its volume is larger, at 92 bytes. Now, it contains information not only about seconds elapsed, but also about every other variable that has changed, such as the number of clicks and various gold variables, as the amount of gold also changed. However, as we have sent all this information to the server and did nothing afterward, our next packet will again contain only timer information. Moreover, once we switch to the main menu of the game, where there is no timer, the size of our packets will reduce to 12 bytes, as they now contain no other information except service info. As you can see, a significant portion of the past month was dedicated to building this data comparison and optimization system. Alongside that, I created a list of commands to communicate with the server and control its functions. For instance, I can execute a shutdown command, which safely disconnects all clients from the server without them losing their progress. If I were to close the server application without running the shutdown command, data wouldn't be saved to the database, resulting in players losing their progress. So running shutdown is a must. Another useful command is clients, which allows me to see all clients currently connected. Obviously, as I'm testing the server on my local machine, there's only one client connected, and that's me. The server is mostly done now. My next step is to upload it to the cloud and conduct testing there. Following this, I'll be focusing on creating an offline progress system. In fact, offline progress is the only mandatory feature that I should implement before releasing the test version and finally presenting it to you folks. So make sure you subscribe to this channel if you don't want to miss it, and hit that like button if you want more content like this. For now though, Thank you for watching and see you in the next video.